One of the most common features in an FPS game is the way that it handles spray from the weapons. Some games use this as a way to control the difficulty and give players a way to demonstrate their skill against others. I'm thinking about Counter-Strike and Valorant. In other games, it's random and mostly there for immersion. Without a good spray, an FPS game can be left feeling dull and lifeless, which is why I've been working on my FPS spray for a really long time now. My last video was in November 2021. Now, I haven't been working on spray non-stop since then, that would be crazy, but I have been iterating over it for the various FPS templates that I have created and released over the last 12 months. But how can you create good spray in your FPS game? Even though we're simulating spray in a 3D space, we're actually faking the whole thing. It's all happening on a 2D plane, which is your screen. For this, we really just need two things: a way to count how many shots you've been firing, or as I call it, the shot count. Some people refer to this as heat, and a vector 2 to manipulate the origin point of your raycast. We can draw up the screen to simulate the spray for the weapon. Even though this is all coming from the camera projection, we can still add a second raycast to ensure the line from the weapon is correct. One thing is for sure, every FPS game needs to have some kind of spray that happens as the weapon is fired. But first, I need to spray you with a word from this video's sponsor, Zenva. If you're excited about game development with Godot 4, then you absolutely need to check out Zenva Academy. They offer easy to follow courses that are ideal for both beginners and intermediate level developers who are looking for structured learning pathways. What's awesome about Zenva is how they make learning fun and practical. You get professional video tutorials, written lessons, and interactive quizzes. Plus, you'll work on real projects building games in different genres like open world, RPG, and even FPSs. Also, Zenva isn't just about Godot. They have courses on Python, Unity, Unreal, and other tools. With one subscription, including a 7-day trial, you unlock over 250 courses and 32 learning pathways. The first 50 people that use the link in the description or pinned comment will get an extra 20% off the first year on your annual Zenva subscription, on top of any existing site discounts. That's a huge saving for a world of game development knowledge, so get in quick. So if you're ready to dive into Godot 4 or explore other game development areas, Zenva is the place to be. Grab this offer and start your game development adventure today. One of the most well-known games with a spray pattern is, of course, Counter-Strike, which has very clear patterns that give the players an avenue to own their skills by memorizing the pattern and improve their ranking. Other games that do this are also Valorant and Rainbow Six Siege. The bullets follow a clear path and there's a little bit of randomness to it. Personally, this is my preferred spray pattern when I play FPS games, although I don't play many multiplayer games much anymore. Random spray in games like Fornite or Halo leave a lot to be desired, and the additional skill that you can display if you know how to control the spray is just a lot more satisfying. The other kind of spray that exists is, of course, random spray, which is kind of just a zone that expands the longer you shoot for. And in my opinion, this is okay for single player games or games where shooting might not be the primary focus, like an immersive sim, or even like an online movement shooter where the challenge of making a hit is keeping the enemy in your crosshairs to begin with. Something like Doom, Tribes, or Quake come to mind. It's not a bad way to do spray pattern. It's certainly easier. All we need to do is calculate a random point between our shot count and raycast to that point. Okay, so let's go over quickly to how shooting even works in my FPS template. When you fire a weapon, the first thing that it does is play an animation, reduce the ammo count, and notify the HUD that the ammo has been used. Visual things for the player. Nothing to do with actually shooting the weapon. The next thing we do is load a projectile. A projectile in my game is an object that does the raycasting for the weapon. It's a component that can do any kind of weapon damage that you need it to. It takes a variable called spread, which you might remember from my last devlog. This spread gets added to the endpoint of the raycast projection. Kind of like drawing a line up a screen, we can project the point from here to collide with whatever is in between. My projectile, of course, have a second raycast that then goes from the end of the weapon to the point in 3D space to find anything along that line that actually matters. This helps to make sure you can't shoot around corners and that projectiles and hit scan weapons have a similar trajectory behavior. But how can we actually calculate the variation? Let's look at the spray paths first. Now that we know where the spread variable is going to factor into our raycasts, we need a way of actually calculating the variation. In my video from November 21, I used a simple curve with manually input vectors and the Pythagorean formula to calculate an increase in spread over the next shot. I thought this was pretty slick, but in reality, it doesn't really matter. What I need to do is create something simple and convenient, but mostly I'm wanting something modular, which is where I came up with the idea of spray profiles. A spray profile are another component that can be added to the weapon, so it makes prototyping a lot easier, which is the entire point of this template. So rather than using a vector 2 for direction and some formula to define the increase in the distance, we can easily just use a path 2D to draw the exact shape that I want. We then can use our shot count variable to cycle between each point. So now I can clone any number of spray patterns if I want to. The final piece is an addition multiplier that we can use for movement or just to modulate if we want to. Now I know what some of you are thinking, that I could just use a curve for this and it wouldn't need to be a node. I could make it a resource and I wouldn't have to load anything at runtime. I could just pull up the data when I need it. And yeah, you would be right. I tried it and I didn't like it. And it's not 100% predictable. With the path 2D, the points drawn can directly translate to what's cast from the viewport. And that's okay. I chose a different path for usability and readability. And sure, there's a little bit of extra overhead, but I don't think it's gonna affect the performance in any material way. So let's stick with the convenience for now. What about random spray? In games like CSGO and Vallorant, there's always a little bit of randomness. So we need a way to add in some variation, and I also want a way to only have random spray as well if I want. I'm going to use noise for this. We're going to take some fast noise light and get a point for the X and Y and just multiply it by the shot count. Honestly, it could be that simple. What I'm going for is an even increase in the chance for it to be within an ever increasing box. That box is something called the shot count or heat. Essentially, with every shot made, the count increases and the noise is multiplied by the count. Kind of like Halo's assault rifle that is just placed randomly. When you release the trigger, that shot count value is reduced down to 0, but not straight away. It takes like a second. So if you shoot in bursts, it won't start from 0 right away, and it just sort of gives that nice random burst effect. Now, random in games, as you are all aware, is not really random. So when I say random, I really mean randomly generated by noise. It's going to be the same every time. I introduced a variable to alleviate this called true random to change the noise seed every shot if a truly random spray is desired, along with an upwards lock. Not super happy with the name of that, but it basically forces the Y spray axis to always be negative, which is up on your screen for some reason, at least in Godot. The other way that I could have done this is with a simple random range between negative shot count and the shot count, but noise allows for both a randomly generated spray, so we get the best of both worlds here. So with all of that combined, you can really start to make some interesting spray patterns. Rather than keeping the two options separate like I have in the past, I've created a slider that can add the random to the path spray, which is how we achieve the same behavior as Counter-Strike and Valorant. If we want an entirely random spray, we can either just remove the path or change its influence to 0. And what we end up with is some really nice spray effects. Take a look now and let me know what you think. I'd love to hear your thoughts on a system like this. This is an open source project, so you can jump into the source code and check out exactly what I've done. Personally, I think it's the best of both systems where you can create something random or a very clear path to follow. Then there's the option for mixing the two and or making the spray better or worse with the multipliers. Someone could easily build out a system where the crouch or the sprint influence the multiplier, but I'll leave that to the users as I don't want to influence too much how the gunplay should work. The sliders are there if you need them. Okay, so that's all for this week. Definitely like and subscribe if you want to learn more about spray patterns in FPS games. In the next few weeks, I will put out a more step-by-step tutorial for people who want to learn exactly how this works. As always, if you want to support me, you can do so on Patreon or as a channel member, where you get access to the pro version of this template, which has an FPS rig and tons of juice to make your FPS game look amazing. Don't forget to check the link in the description for that discount on Zenva as well, especially if you're just starting out. Thanks, and that's all for this week. I'm Isaac from Chef Games, and I will see you next time.